Hello students, today we'll deal with the topic number theory, BSc 3rd semester paper 1. I am Sujata Tallur, assistant professor in mathematics. In this session, we'll discuss about the Wilson's theorem and converse of Wilson's theorem, and we'll solve some examples on it. So let us start with the Wilson's theorem. The statement of the Wilson's theorem is, if P is prime, then prove that P minus 1 factorial plus 1 is congruent to 0 mod P. The proof is as follows. Let A be any positive integer less than P, then A, 2A, 3A, so on P minus 1 into A have different remainders when divided by P. So let us take A1 belongs to 1, 2, 3, so on P minus 1 such that A1 into A is congruent to 1 mod P. If A1 equal to A, then A square is congruent to 1 mod P. So therefore P divides A square minus 1 or P divides A plus 1 into A minus 1. Since P is prime, P does not divide A minus 1. Therefore, P divides A plus 1. So, thus A equal to minus 1 or A equal to P minus 1. So, therefore, A1 square and P minus 1 square are the only squares which leave the remainder 1 when divided by P. Except these two numbers, if any other number of the set 1, 2, 3, so on P minus 1 is considered, then these are AI, comma AJ, such that AI into AJ is congruent to 1 mod P, where I is greater than equal to 2 and J is less than equal to P minus 2. Now, therefore, all the numbers of the set 2, 3, so on P minus 2 can be grouped into pairs so that their product is congruent to 1 mod P. So, therefore, 2, 3, so on P minus 2 congruent to 1 mod P, and also we have 1 into P minus 1 is congruent to minus 1 mod P. Multiplying these two, we get 1, 2, 3, so on P minus 1 congruent to minus 1 into 1, that is minus 1 mod P, or P minus 1 factorial plus 1 is congruent to 0 mod P. Now let us see the converse of Wilson's theorem. The statement of the converse of Wilson's theorem is, if P is greater than 1 and P minus 1 factorial plus 1 is congruent to 0 mod P, then P is a prime number. So proof goes like this. If possible, let P be a composite number. Let P equal to P1 into P2, where P1 is greater than 1 and P is greater than P2. So P1 lies between 1 and P minus 1. Therefore, P1 divides P minus 1 factorial. Call it as equation 1. Now, P equal to P1 into P2. So, therefore, P1 divides P. Also, P minus 1 factorial plus 1 is congruent to 0 mod P, which is given. So, therefore, P divides P minus 1 factorial plus 1 and P1 divides P. So, by transitive law, it follows that P1 divides P minus 1 factorial plus 1. Call it as equation 2. From equation 1 and 2, it follows that P1 divides 1, which is a contradiction to the hypothesis that P cannot be a composite number. So, therefore, P must be a prime number. Now, let us solve some examples on Wilson's theorem. First one, show that P6 factorial plus 1 is divisible by 7. So by Wilson's theorem, p minus 1 factorial plus 1 is congruent to 0 mod p. Since 7 is a prime number, put p equal to 7 in equation 1. So this is 6 factorial plus 1 is congruent to 0 mod 7. So that follows that 6 factorial plus 1 is divisible by 7. Next, second example, prove that 18 factorial plus 1 is divisible by 437. Now we can write 437 as 19 into 23, where 19 and 23 both are prime numbers. Since 19 is a prime number, by Wilson's theorem we can write 18 factorial plus 1 is congruent to 0 mod 19, or 18 factorial plus 1 is divisible by 19. Call it as equation 1. Now similarly 23 is also a prime number. By Wilson's theorem we can write 22 factorial plus 1 is congruent to 0 mod 23. So 22 factorial can be written as 22 into 21 into 20 into 19 into 18 factorial plus 1 is congruent to 0 mod 23. Call it as equation 2. Now 22 can be written as 23 minus 1. 21 can be written as 23 minus 2, so on. So this can be written as multiplication of 23 plus minus 1 into minus 2 into minus 3 into minus 4 into 18 factorial plus 1 congruent to 0 mod 23, or 24 into 18 factorial plus 1 congruent to 0 mod 23. So 24 into 18 factorial plus 23 plus 1 is congruent to 0 mod 23, or 24 into 18 factorial plus 24 congruent to 0 mod 23. Now if we take 24 common, it is 24 into 18 factorial plus 1 congruent to 0 mod 23, or 18 factorial plus 1 congruent to 0 mod 23. Call it as equation 2. Also 19 comma 23 equal to 1, that is 19 is relatively prime to 23. From equation 1 and 2, 18 factorial plus 1 is divisible by 19 into 23, that is equal to 437. So I have given some examples to solve on your own. First one, prove that 712 factorial plus 1 is divisible by 719. Second one, 12 factorial plus 209 is divisible by 221. Third one, 28 factorial plus 1 is divisible by 899. For this session, I have referred the following textbooks. First one is N.P. Bali, that is Algebra, Lakshmi Publication. Second one, U.R. Tyagi, the Elementary Number Theory and Trigonometry book. Third one, G.K. Ranganathan, a textbook for mathematics. And S.S. Bhusnurmat, a course in BSc Mathematics books. So, thank you students. Thank you for watching.